matrix now. Okay. Okay, thank you, everyone. Welcome to ECE 3500. My name is Xiang Huang. You can call me Xiang. And this is my contact email. And no, wow, okay. Today we will learn some basic knowledge of how to use MATLAB. I think MATLAB is the abbreviation of matrix laboratory. It's an easy and powerful tool. And maybe you will think of the movie Matrix, but I'm I'm sure that if you master the MATLAB, you can be the Neo in your world. Okay, so let's for the MATLAB, let's firstly open it. Now this is the interface of MATLAB. The center is the command window, and the right-hand side is the workspace. You can type your command here in the window. For example, if you type A equals 2, it means you assign the value 2 to the variable A. Okay, you can see A has been stored into the workspace. Yeah, it's very interesting. But this is the easiest operation. So let's focus on today's material. I will click this one. I will click this one. Okay, MATLAB MATLAB is a matrix laboratory, so the basic elements are vectors and matrix. So matrix and vectors. Here I have defined a 225 by 225 matrix. You can know what it means, right? Because it's just data. But I will show you in a proper way. For example, if I use the built-in function image show, you will see what's this. Oh, it's a cute Pikachu. Here I have the title this picture as Pikachu, and also use the X and Y label. X for the x-axis is the width, and for the y-axis it's the height. Okay. Now, so this is the information we want to. Suppose that this is the information we want to transmit. However, before transmitting, what we want to do is to modulate do some modification to make this information to be signals. For example, now here is what we want to do. You can see I have to do this modification in the matrix A. The every value in this matrix is 0 or 1, but in the but after I do the modulation, each 0 has been changed into -1, and each 1 has been changed into the positive 1. Actually, this is the BPSK modulation. It's what you will learn in the rest of this class, this course. So, so this modulation helps. This modulation make the information to be the signals that we want to transmit through the channel. Okay, in the channel, actually, if we just channel here, this is X, and this is the received signal Y. The basic channel is add noise, because the noise are everywhere. So you cannot avoid the noise. So here I define the noise like this. Firstly, we must and to define the noise, we must define the noise power. Here I introduce the ratio of signal to variance power. Suppose that the transmitted signal power is P and the noise power is N, and in dB, okay, in dB, okay, then what's this, how to calculate it, then it's 10 log S NR divided by 10. So according to this formulation, if let me see. Let me see. Noise power. Suppose that we're assuming that the transmitted signal power is 1, and so if we want to the ratio of ratio of signal to the noise power be higher, and then the noise power must be small. But if we want to the ratio of signal to noise power to be small, the noise power should be high. Yeah. So in this way, I have defined the noise power as this way, and this N matrix is a 225 by 225 matrix. It's a noise matrix. So, so what we need to do now is add this noise into the transmitted signals X. So the at the receiver, we will receive a very disrupted Pikachu like this. You can see here. Oh, you can, yeah. You can't see anything. You can't see anything from this picture, right? Because it is strongly disrupted by the noise. And by doing this operation, actually, I have to use the addition of matrix, if you can see here. And for the addition of matrix, you must maintain both matrices have the same size. Yeah, y has the size of 225 by 225. So the n and the x should have the same size. And so this is some basic operation for matrix addition. Okay. So the basic. Oh, I have forgot one thing. For the modulation, if you notice that A is a matrix, 2 is a scalar. A matrix times a scalar means that every value in the matrix is multiplied by this scalar. And this is the same for the malus operation. Okay. Okay. So let me ask you a question. Since our noise is so strong, how can we get the information of Pikachu at the receiver? I mean, how to recover Pikachu from this powerful noise? You guys have some thinking? Right. But noise is what you can know, right? Because it's random. You can know what noise it is. Even though even though you can know what you have transmit, because if you have know your information, what's the meaning of get that information? I mean, what I want to transmit is what you don't understand or what you don't know. So if you you understand what I mean? Yeah. So do you guys have some thinking? How to recover Pikachu from this strongly disrupted picture? There is the easiest way to do that. Can you think about it?
It's like we just do the signal that's the opposite.
Sorry?
I mean, we just signal to the opposite, just to, like to cancel out distortion.
Oh, sorry, I didn't follow you.
Just maybe it is. No, never mind.
Okay. Actually, many many scientists has figured out many ways to recover information from some disrupted signals. But before that, the easiest way is to resend this image many times until you get your information. So let me. So this is the easiest way. So here I just resend this information 20 times, and you can find I will recover the Pikachu from this noise. Let's try it. Noise, 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 noise. Okay, at the end, the Pikachu has been recovered. Yeah. And do you know why? Why did happen? Why we can repeat many times to recover our Pikachu? Yeah.
I guess like because the noise is random, right? So if you send it a lot of times and you keep overlaying them over the noise, it's like because I guess the message is constant, right? So if you keep doing it over and over again, it would come out.
Yeah. That's correct. That's correct. But that's correct. However, there are some. Our noise is random. It follows some distribution. If actually the Gaussian distribution. Let me. And do you remember I have do some modulation, right? Okay, so I have changed the 0 to be minus or plus or positive, no, sorry, -1, and changing the 1 to be the +1. For the Gaussian distribution, if a Gaussian distribution follows the mean 0 and the variance of 1, its distribution is like this. However, after I do the modulation, there are two distributions combined like this. So for each, if we look into the right-hand side, most part are in the correct room. Only a very small part focus on the error zone. So that's why we can resend our image, because noise is random, and there is a small possibilities to have a error. So if we keep in transmitting our signals and combine them, we can recover it very good, very well. Let me change this one. For example, if I repeat 40 times, we see it will be recovered very well. Sorry, it's very slow. Yeah. Look, there, even though there's still some white dot around the Pikachu, but I think it has been recovered. So for this example, I just want to show some how to define our functions. Since MATLAB is very powerful because of, sorry, wait a moment. MATLAB is very powerful because it has many built-in functions, but these functions are based on basic algorithms, some classic algorithms. But in our research, we always want to develop our own algorithm. So we must know how to define our functions. For the functions, firstly, we should have this declaration function and the end mark. And the next thing is the output variables. You can name whatever you like. And the next thing is the function name. And then it's the input variables. In the rest of part is the programming block. Yeah, here I have used built-in functions and zeros matrix. Zeros is to create a matrix filled with element 0. So, and here I used the for loop to repeat transmitting our signals through the channel, and do some showing, and then after I get all the images, I get the average value of all transmitted pictures. Yeah, I think this function is actually MATLAB is very easy to understand. And if you have some basic knowledge of other languages like C++, Java, it's very easy to use. I don't think it will be hard for you. So this is what I want to talk in this class. Since I think I have covered all materials in the paper of lab 1. If now I think you can try do the exercise in lab 1. If you have some questions, you can ask me. Yeah. Yeah. Okay. Over. Dun, dun. Oh. In the rest of this class, I don't think it's necessary to stay on Zoom or stay in this classroom. You can go if you wish to go. Yeah. Okay.
I have a question about, so on the syllabus, it said that we have lab on Wednesday, on Friday.
Yeah.
It is because we have 2 lab on 1 week or just on 1
Oh,
day?
for this 2 level in 1 week, we just teach the same. So you don't need, you
Oh,
can just
okay.
join 1 lab. Yeah.
I have a question.
Okay. Mm-hmm.
So I'm not sure I quite understand what the transmitting part did
Oh.
to the signal X.
Okay.
Yeah.
Sorry. Wait a minute. What do you understand? What you don't understand is this equation or the meaning?
Yeah, just the meaning. Like, what is it doing to the signal?
Okay. Since you can think about this. Originally, we only have 0 and 1 in our information. If we transmit this pattern, and this the distance between these two symbol is just 1. If we transmit -1 and 1, you can see the distance is bigger, right? It is larger. So this will help us reduce some noise, since if we look into the Gaussian distribution here, sorry, this is our transmitted pattern, and through the channel, we can find if we focus on this right-hand side, the correct zoom is around this one, but for the error zoom, it's only about this one. Since the singles is less than 0, but what we want to do is make the single is greater than 0. However, for the if we don't do the modulation, like this, if we don't modulation, the 0 and 1, if we don't do modulation, maybe most part will overlap. So
Right.
it will be hard to tell what symbol we have transmitted. So I think the reason is that the distance we want to these two symbols distance to be bigger or to be larger.
Okay.
So, okay.
So is that what the equation is doing? Just making the distance larger so we can tell apart the signals?
Yeah, that's correct.
Okay, got it.
Thank you. Oh my God, this. Stop recording.